Okay, thanks everyone for joining again in today's session. My name is Mohammed Qadir. I'm the technical lead in solar division of Jubaili Brothers. Today's presentation is on power control options using Huawei Fusion solar inverters. These presentation as goes along, I would like you guys to put your questions in the chat section by clicking the question mark icon, and then these questions will finally go to the Q&A mode where I will be answering at the end of my webinar one by one. So going ahead with the presentation, power control options, grid tie point power export control introduction. So in order to improve a grid stability, power export control is required where the utility or network operator requires to restrict the amount of energy from PV system that goes into the grid. So for power export limitation, multiple Huawei devices might be required. The basic is Huawei inverter itself, within which you will also require a Huawei power meter or a third-party power meter directly communicating with the inverter or through a secondary device such as Huawei smart dongle or smart plugger. So normally the purpose of grid limitation is either your network doesn't support the big fit towards the grid itself, or you are limited by the grid authority to generate certain amount of power, and you have to control your output if the generation goes above that value. So application scenario for power control is that you can have a single inverter where you would be needing a power control. You can have multiple inverter using a smart dongle, or you can have multiple inverters and use a smart logger in that case. In each of these three cases, the latency period or the response period from the time the power exceeds the value which is defined, which needs to be controlled, till the time it is controlled by the inverter itself or the device, such as smart dongle. Smart dongle can take around 2 seconds. In case of the dongle, it is up to 5 seconds, the response period. So whenever you are installing the system, you will have to do some certain configurations in order to make sure your system is doing such power export control. And for that, in case of a single inverter, you will choose as closed loop controller inverter. In case of multiple inverter with the logo, you can have a smart dongle as the closed loop controller. In case of multiple inverter with a smart logo, the closed loop controller will be a smart logo. Now, since as I said, you will also be needing basically a power meter, so you will be either using a smart power sensor from Huawei or a third-party power meter. Such power meters are already given in the smart dongle or the smart logo manual, which can also be sent out from our point of view, and we can give you this power meter list, which you can source through third party as well and do the zero export control or the type of control that you require. So there is certain requirements for the power meter which is mentioned here. Huawei provides a single phase power meter DDSU666H and three-phase power meter DTSU666H, and apart from that, there is an available white list, as I said, which can be shared to you after this presentation separately. So, in different scenarios, you have multiple different inverter models. With the single phase and multiple inverter with the dongle, there is a list shown in this table. Similarly, for with the case of multiple inverter with the smart logo being used, there is certain inverter models that can be supported. So in all these scenarios, the platform which you will be using to configure, control, and monitor is the Fusion Solar app or the Fusion Solar browsing platform. We go ahead with the case of one single phase inverter power export control. Uh, if you're using our small range of inverter up to 20 kilowatts, so this scenario will apply with the single phase, where you will be directly connecting a smart power sensor directly to the inverter. Typically, this slide is for the single phase inverter. You will be choosing our single phase power sensor, connecting it to the RS-485 port of the solar inverter, and thus connecting the power meter to the voltage line at the grid incomer in your point of common connection. And similarly, you will have a current transformer, which will be also supplied with this power sensor on the grid side with the arrow key uh, uh, directing towards their load side. So sometimes we have seen that the EPCs do this mistake that they don't care about this arrow key. So the CT has a direction shown on it. You need to make sure that the direction of the CT is towards the load side, but connection on the grid side to know whether the current is going towards the grid or coming from the grid side. So in case there is a power going towards the grid, the current will be sensed, and in that scenario, the inverter will immediately respond and reduce its output power equivalent to the load requirement, such that there is no power going towards the grid. So one three-phase inverter power export control, similar to the single phase, the only difference here will be that you will have a three-phase smart power sensor from Huawei, which will be directly connected to the inverter. And in case of three-phase, you will be using three voltage lines connected to the power sensor. Similarly, three current transformer, which is supplied with the power sensor, you'll be connecting it to the smart power sensor. And these SLD is shown to you on the right side of the screen. You have to understand that uh, these type of scenario you can also be able to install a smart dongle or a 4G dongle. So that table in this screen shows to you that which inverter model supports which of the dongles. So the dongle with the WLAN FE feature supports from 3 to 20 kilowatt, and the 4G dongle supports from 3 to 100 kilowatt, just excluding the 36 kilowatt inverter model. And since Huawei is going to be introducing very soon the new range of inverter, which will be a replacement to 36, that inverter series will also be connected to the WLAN and 4G dongle and can be used for communication and export control. Multiple inverter power output export control with dongle. Now, in case you have multiple solar inverters, uh, the models could be different. So you must make sure that the inverter which is connected directly to the smart power sensor is compatible with that. In the previous table, or even in this screen as shown, these inverter could be, in case of a WLAN-E, from 3 to 20 kilowatt, to which you can connect your smart power sensor, and thus making that 3 to 20 kilowatt, any of those sizes, a master inverter in your PV plant, and making the rest of inverter models as a slave inverter. So the function will be activated through a smart dongle. The closed loop controller will be a smart dongle in this scenario, and the maximum number of solar inverters can be up to 10 inverters. And connection type would be similar to the previous one. As I said, you will be using a power meter. Either it could be from Huawei, a smart power sensor, which can be adopted to a 170 kilowatt AC output PV system, or if you have a PV plant larger than that, where the AC output is more than 170 kilowatt, you will be using a third party power meter, which can be shared by us with you. Multiple inverter power export control scenario with a smart logger. So if you have multiple inverter, maybe which could be of any quantity, you can always use a smart logger as well, which is a universal logger for all the different inverter models that Huawei has. And the connection from the smart power sensor in this scenario will be it will be going to the smart logger, and then from the smart logger the connection will be done to the uh, inverter. And the smart logger will also do the monitoring and also does sending the command for the changing the MPPT points in case a control is required to reduce the output of the PV plant. Again, similarly, the connection for the power meter with the CT and voltage lines will be as shown on the right side. These smart logger can be connected up to a maximum of 80 inverters. Okay, now we just went through the different ways of connecting a PV plant and having a zero export control on a hardware side. Now we will speak more on how to do this configuration on the Fusion Solar, which is the interface for your inverter, which is the interface for your smart dongle or the smart logo. So whenever you will be commissioning your PV system, the Fusion Solar app, you, you will have it in your mobile. You can scan the barcode given on the dongle or the inverter, and you will go. That will take you to the quick setting of the PV plant. So the first thing that you will do is that under the quick setting, you will scan the one of the inverters or the dongles. Whenever once that is done, the next components within that PV plant will be automatically detected. So if you have a smart power sensor in that PV plant, that will be automatically detected, which is connected to this inverter and dongle. So the next scenario is that you have an option of manually adding the power meter. So how will you do that? Manually adding smart power sensor is under the quick setting. You will find device maintenance. You will click that. The next step will lead you to the option of add slash delete device. You will click that option, and then that will prompt you to the next window where you will have the option of adding power meter. So you will click that power meter, and that will lead you to the type of control that you want. So select the connected smart power sensor model, either it is a single phase or a three phase with the right model from here, and then the communication address usually kept as 11. Power export control setting in Fusion Solar app. Now you have detected your inverter, you have detected your smart power sensor, either by manually adding that or by automatically adding that. So the third option within the same commissioning phase, you will find on the left screen, on the left window, you can see is the power adjustment. You will click that. That will prompt you to the next window where you will find the option of grid tie point control. So you will click that. It will since you are doing some sensitive setting right now, so inverter will ask you to put the password in order to go ahead. So the password by default from the Huawei side is 5 times 0A. After putting that password, it will lead you to the option of either active power control or the reactive power control. Since our purpose is usually active power control, so you will click that, and that will prompt you to the next window. So now you have the option of set the power export control mode and parameters. So you will click that, and then the next slide will tell you what next options you will have. So now under the export control, you will have three different ways. One way is the unlimited mode, which is normally the case of every inverter by default from the factory being set as unlimited mode. And the next one is grid connection with zero export. So you have an option of that. The third option is power limited grid connection. We will speak of all these zero export power and also the power limited grid connection in the next slide. So grid connection with zero export. Uh, Once you select the type of control as zero export, the next option is what is your closed loop control. So as of my second slide, which I showed to you, there is two options. Either you use a single inverter or multiple inverter. With the single inverter, the closed loop controller you will choose is inverter itself. And in case of the multiple inverter, the option that you will have on this tab would be smart dongle slash smart local. After choosing this, uh, okay. So now talking of a single phase scenario on how the zero export control setting would apply and how this would work. Let's suppose there is a PV system, as you can see on the right side in the SLV, that the solar PV plant is capable of generating 5 kilowatt while your load is 6 kilowatt. It means your solar PV system is generating less than what load requires. So 1 kilowatt additional is taken from the grid side, thus to accommodate the total power required by your load. All of a sudden, what happens is that this load, which is 6 kilowatt, drops to a 3 kilowatt, which is which is shown in the second SLD on the left side, it drops to 3 kilowatt. Since you have configured zero export control setting in the single phase, what it will do is that it will immediately reduce the power from 5 kilowatt to 3 kilowatt, so that there is no additional power going towards the grid. So the arrow key is shown towards the grid side, shows you 30 kilowatt. This is what will happen in a zero export with the total power limitation. Zero export control setting with the three-phase total power limit. Now, in case of three-phase, you have now two options. You can control your output of solar inverters with the option of total power limitation or the single phase limitation. First, now we will speak about total power limit. After you have chosen the grid type point control as zero export and your right closed loop controller, next option that you will have is either limitation mode. What limitation mode you want to apply? Is it based on the total power or the single phase power? Now we will speak on this slide about the total power. What happens when you apply the total power? It will see what is the total sum of the load on all the three phases. As you can see on this screen, the load on all the three phases sums to around 6 kilowatt. Therefore, the total output of this inverter is 6 kilowatt. Though this inverter might be capable of generating more than 6 kilowatt, but it has limited its output such that the 6 kilowatt equals to the sum of all the three phases. In this scenario, since the three phases won't have equal load on all the three phases, so there might be a chance that on one of the phases there would be export towards the grid, on one of the phases there could be no export towards the grid, and one of the phases there could be extra power taken from the grid side in order to balance this whole system. So this is a type of control called as total power, but which still has the chances of power being exported toward the grid. But in net, if you see how much power is sent towards the grid, is equal to zero. As in this scenario, 1 kilowatt goes towards the grid, and 1 kilowatt is also taken from the grid side. Thus, the balance is zero. The next type of control is the single phase limit, and this is the most reputed way of doing the zero export. What happens in this scenario is that you will apply the limitation mode as single power, and the inverter will look at which phase is having the minimum load. In this case, as you can see, the three phases is having 120 kilowatt load, and the inverter has limited its output based on the phase which has smallest load, and thus providing you an output power limited by the phase which has minimum load. In this case, there will be no power being exported towards on any phase towards the grid, and rather there will be extra power taken on the other phases where the load is higher than the lowest power phase. Response time setting of zero export control. So by default, the inverter closed loop control is around 2 seconds, because as soon as the power sensor reads the data on the grid side that there is some extra generation going towards the grid, till the time the inverter responses to that power excess going towards the grid takes around 2 seconds. So in case of a smart dongle, as described earlier, it's around 5 seconds, and again, it's in case of the smart dongle, it's around 2 seconds. So sometimes your consultants or requirement from the customer side would be to make sure that this response time is less than 10 seconds or 5 seconds or 2 seconds. So you make sure that you are using the right type of control mechanism in order to make sure that you are meeting the criteria of your consultant in order to control the output power of your PV plant. We spoke of the two type of zero export, which is single phase, and the total power limitation. We go ahead with now the next type of control, which is called power limited grid connection. Okay, so Under the grid tab point control, you have the option of selecting the power at this point. The accuracy of these would be around plus minus 5%. Input inverter output power adjustment. Now there is another way that you can control the inverter output is based on what rated output or what percentage rated output should the inverter provide if the inverter is capable to. So in this scenario there won't be need of any power meter as you can see in this screen, because you will just configure the inverter to limit itself to certain power. So what options do we have in this scenario? Okay, now from the and under the in the commissioning phase, when you will be uh, detecting the devices in your PV plant under the quick setting, next option would be to go to the power adjustment. Under the power adjustment and the tab, you will find the active power output. So instead of grid type point control, here you would select the active power control output option, which will prompt you to the next window of select active output power option. So you have multiple options in this, and then we will discuss each of them now one by one. The first option under uh, fixed power fixed power limitation is this control of active power in terms of percentage. So you will put a percentage here, and let's suppose in the scenario shown on the screen, the percentage duration or percentage output power is fixed up to 50%. At the inverter on these PV plant installed is 6 KTL-M0, which can provide you a maximum of 6.6 kilowatt. Since we have configured it to give a maximum of 50% of its rated power, maximum power, so it is limiting its output power up to 3.3 kilowatt. Although the PV capacity is high, generation could be more than this, but since you want that these inverters should not provide you more than 3.3 kilowatt, more than 50% of its max output power, so it will limit itself to that particular output power. Okay, inverter active power control on fixed value. Now, in the previous slide, we discussed the limitation of the inverter in terms of percentage. In this screen, you see that we have the option of limiting the output power of inverter based on the kilowatt that we want. Let's suppose you have a 50 kilowatt inverter, you want to limit its output up to 30 kilowatt. So you will put here as 30 kilowatt, and thus 50 kilowatt will react as a 30 kilowatt and will not let your PV plant generate more than 30 kilowatt. So in the scenario shown on the screen, you can see that the 6 kilowatt inverter has been configured to provide a maximum of 3 kilowatt, thus being potent enough to generate more than 3 kilowatt. Even the inverter is limited by the active power control as a fixed value of 3 kilowatt. So 3 kilowatt will be generated, and then if that meets the requirement of the load, it will provide that to the load, and excess will go towards the grid side. So this is how you will do the derated power control based on a fixed value in the fusion solar. So we spoke of all the different scenarios of active power control. It was a very short presentation, I believe, but yet very informational. Thank you guys for joining this session. If you have any question, please put your question in the chat section by clicking the question mark, and then the questions will go to the Q&A mode, and I will be answering them now one by one. I'm opening the Q&A session. These presentation will be shared to you after this webinar. Okay. So the first question I have is from Abira Khan. She is asking how Huawei inverters compensate reactive power requirement for the connected load for available solar power. So Abira, these option is also available, and you have the reactive power control. You can do it based on the percentage, based on the power factor that you require. So this is also an option. And under the power adjustment, you will again go to the grid type point control, and you will find this option of reactive power control. For more information on the reactive power control, I would suggest you to send us an email on technicalsolar.ua@jubaili.com, and we will get back to you. Abira is again asking another question: if grid is solely responsible? No, you can do also your own way of uh, limiting your reactive power. Grid is not always responsible for that. Huawei meter is compatible with other inverter like SMA or Fronius? Mr. Zafar is asking. Zafar, as you know that Huawei inverter or all grid tie inverter looks at what is the grid voltage and frequency. So it is irrespective of whether you have a SMA inverter or Fronius in that PV plant. You can add a Huawei inverter as well, and thus Huawei, SMA, Fronius all can work together and supply its output to the grid, and there is no issue in that. The monitoring of all the three systems can be common using a third party monitoring platform, or you can have individual monitoring of all the inverters of Huawei using Fusion Solar itself. Okay, so we have the next question. If we are using zero export device, do we still require approval from DIVA ADDC for net metering? After this is a very good question. And for DIVA, if you're installing a PV system and you are using a zero export, I haven't met such requirement because DIVA is allowing you to export the additional power towards the grid. So why shouldn't you be doing that? And if you're installing this in an emirate such as Sharjah or other emirates in UAE, you still require approval from the authorities, as I have heard. So that is something from the public authority, local credit authority, which should be asked. And I guess yes, and this question has an answer yes, and you will require still approval from the authority that we are doing zero export PV plant installation. Adnan Mirza is asking in the first slides where the dongle device is connected to the master inverter along with the power meter. Can we use M-bus communication scenario with 50 kTL and 4G dongle? No. 4G dongle does not support M-bus communication. You must use our Smart Logger 3000B in order to do M-bus communication. The Smart Logger 3000A does not support as well. Jasim is asking, is Huawei inverter allowed to use the generators as grid with zero export control for grid absence areas? Jasim, uh, question is good, but whenever you will have a generator, you won't be doing zero export, rather you would be also making sure that your generators are running at their minimum rated load. So thus, you should rather be using a hybrid controller in that scenario. But yeah, grid generators can also work as a grid, and if your generator has a minimum rated load of zero, then you can do zero export control with the generator as well. Faz Farooq is asking, is current transformer needed for zero export, or is it very important that you must have Sorry guys, we had a little interruption in the internet, so I'm back again. The question from Fast Farooq is current transformer needed for zero export? Yes, it is required to have a current transformer with the smart with power sensor or any third party power meter that you would use. Why is that? Because current transformer is actually measuring the amount of current that is being taken from the grid or the amount of current that is going towards the grid. In order to calculate how much power that is equivalent to, the voltage is also thus calculated from the point of connection through the cables that you are connecting to. The multiplication of the current and voltage, thus you know, is a power value which is being read by the smart logger and accordingly reacting if a control is required. Next question is, what is the max capacity of inverter? Is it only string inverter or no? Max capacity of inverter, if you are asking about our product portfolio, we have low voltage up to 100 kilowatt, we have medium voltage of 800 volt up to 200 kilowatt, and in terms of zero export solution, using our smart power sensor, you have a limit of maximum of 170 kilowatt, which you can use our smart power sensor with. If you're using a third party power meter, using a smart logger, you can go up to 1 megawatt of PV plant to do zero export with. And if you have a 1 megawatt, more than a 1 megawatt PV plant, when you still need a zero export control using Huawei, you will be needing a third party data logger as well in order to control your PV plant instead of a smart logger, because uh, the 2 second time period or the 2 second response time will be increased when the 1 megawatt PV plant is installed, or more than 1 megawatt PV plant is installed, and that's scenario you need a faster response, and thus you will be requiring to use any third party data logger which can send and communicate with the inverter faster than the smart logger. So most of the cases that we have seen, the PV plants are less than 1 megawatt where the zero export is required, and thus our smart logger justifies most of the cases to be used in. So next question, can I use this inverter with DG? What control methods do you suggest? If you mean diesel generator by DG, then yes, you can use, and you will be needing a hybrid controller, as I said earlier, and thus you can use Huawei inverters in parallel to diesel generator and make hybrid PV system with generators. The hybrid controller will make sure that your generators are running within its minimum rated load, and thus its life is not affected. Sharif is asking, if we are using export on a traditional residential meter, given the 5% accuracy ratio, is that acceptable? Now, the 5% accuracy ratio uh, is, I believe, I discussed on the on the grid tap point control with fixed value is 5% accuracy ratio. With the zero export control, these accuracy is much better. So you have to be speaking to your grid authority that what is the latency period that is acceptable by your our PV plant. As I mentioned earlier, the response time from a smart logger or the inverter itself is around 2 seconds. So your grid authority should be basing their approval based on the time response that our inverter or smart logger has. So the accuracy is much better than 5% in case of the zero X. Is Iraq authority has on-grid facility? Jasim, this is a question I believe which the authority themselves can better answer. But I have heard that you can do zero export PV system in Iraq, and more information on how and what is the maximum capacity based on the connected load. The Iraq authority can better answer that. Uh, the next question is, can this inverter be used with battery for smoothing power control? Now, we have a lot of different inverters. Our single phase inverter, there is available battery model from LGK which you can connect with, and that you can use uh, for charging the battery when there is excess power generation happening in the day. Otherwise, the maximum power generated in the day will be going towards your load, and when there is excess generation, that is only when the excess power will be stored into that LGK battery. And when there is grid available in the evening and your load is high, your generation from solar is less, you can use a combination of your solar generation and the battery in order to run the load. Later in the evening, when there is no solar, still your battery is charged. Again, you can use the battery in order to give the power to the load. But if the grid goes off, this inverter will not work because the grid is always required since Huawei inverters are on grid. In the near future, Huawei is going to be introducing uh, special inverter new versions where Huawei will also provide their own battery series along with the inverter, which can be also used for off-grid application. Adnan Mirza is asking, can we use EMIs with the smart dongle 4G scenario or only the smart logo? Good question. EMIs, if most of you is not aware, is actually environmental monitoring instruments, normally known as weather stations. These sensors cannot be used with the 4G dongle because it don't have connection points for the COM port or the TCP connection, Modbus TCP connection to the 4G dongle. So the only way that you can use weather station is when you have a smart logger which can also speak with your sensors as well. Adnan Mirza is asking, I believe the connection was lost. My question was for residential scale inverters or those which are compatible with the 4G dongle. Can we connect EMIs directly to the inverter through RS485 or a smart logger can be used? Uh, as explained again, you will need a smart logger in whichever size of PV system or whichever size of inverter you are using from Huawei. So you must use a smart logger in order to communicate with the weather station or EMI. Normally, for a small PV system such as residential scenarios, you do not need to have a weather station. So we have a question from Litwana. Can I replace fuse boxes with circuit breakers? What are the pros and cons? Um, this is a question which I would say was not discussed in these slides. And if you have this query, I would say that with Huawei inverters, you do not need actually fuses because we are connecting two strings to each of the independent MPPTs. In one of the string doesn't work, the working string will have a reverse current of maximum 10 ampere, which is within the limits of the non-functioning string. Thus, there will be no any damage to the non-working string due to the backfeed current. So no fuse box is required, and all the strings will be directly terminated to the Huawei inverter. In case you need breaker in order to switching, yes, you can use, but fuses are not required, and you are not recommended to use fuses when you are using Huawei solar inverter. Tanveer is asking how many inverters we can connect uh, together for export controller, and what will be the method of inverter connection, lane or dongle. As I said earlier, there can be multiple scenarios, single or inverter, and multiple inverter, and more than 10 inverter. If you are using up to 10 inverter, you can have a maximum of 10. With the 10 inverter, you can use a smart dongle, and you must be using one of the smaller range of inverter, which is actually compatible with the smart dongle. Otherwise, if you are using none of the compatible inverter uh, with the dongle, then you must have a smart logger in the PV plant in order to do the zero export control, and the maximum number of inverter will be 80. So Talha is asking, one DTS666H can be used with 4 or more 60 kTL please guide required for monitoring purposes. This question is a bit not clear for me. If you want to install DTSU with the 60 kTL inverter, you can install, as I said earlier, up to a maximum of 170 kilowatt, or alternatively, the PV plant should provide a maximum of 250 ampere output, and then you can use a DTSU 666H power meter, and that's you can also do the monitoring on our Fusion Solar. Fast Farouk is asking, do I need to install external SPD with Huawei inverter? Uh, Huawei inverter has built-in SPD. As such, you will not need it to install any external SPD unless and until your local authority requirement says that the length, uh, let's suppose the DC length is up to 100 meter, then you must use an external SPD as well with the inverter. So such requirement is not on the inverter side, but yeah, if there is a requirement on the local authority requirement side, then you must be using an SPD. Do I need to install external SPD? Again, this is the same question. We would like to move on. Alexander is asking, can we use Huawei inverter with Victron energy inverter, charger in AC coupling, and also have zero injection to the grid? Alexander, you can do AC coupling with the Huawei inverter. When you're doing actually AC coupling, it automatically does zero injection towards the grid. So you don't need any power meter in that system unless you want to monitor on the grid side what is coming from the grid. I believe the questions are now finished in the Q&A mode that we had. If there is any further question, please send us via email uh, to the email address which I am mentioning now on the chat section, and I would be happy to assist anyone that would be sending or having any technical concern. So that email ID is technicalsolar.uae@jubailibus.com. Here we end up with our Q&A session. We have a small event survey. Please fill up this small survey. We would like to make our presentations better in the future. I'm very sorry again for the short interruption due to the internet that we had, and we'll make sure that such interruptions do not occur again. Please fill this up, and thank you very much everyone for joining this session. Again, I would say if there is any query, please do send us out the email on the email ID which I have mentioned in the chat section. Thanks, everyone. Have a nice day.